So here we go. We're talking about a little more challenging complete the square. Well, let's make sure you get plain old-fashioned complete the square first. The point of these is you're starting with an equation that, well, actually that one was perfect square in the first place. That isn't the perfect square, like that. Okay? And you're trying to make it into a perfect square so that you can see the vertex. Because once you write it and do this complete the square deal, you'll get a perfect square which will have an answer that's in vertex form. Okay, so do you remember this part where you put in the boxes? Plus a box, minus a box. So it's the exact same thing as the thing before, it's just got two boxes there. One's plus, one's minus. And can you tell me why? Why do I need to cancel out something like that? Why can't I just add 2? Because I wanted it to be 2 or 5 or whatever this number is. Why does it have to be these two boxes? Yes? Yes, whatever you add, you have to take away. That'll keep this equation balanced. See, if I have an equation like 5 equals 2 plus 3, right? What if I want to add 1 over here? Can I just do that?
Sure.
Only if I add 1 over here. But another way to do it is only if I subtract 1. See what I mean? Okay, that keeps it balanced. All right, so that's why we're doing that extra box, is to keep it balanced. Now, the little German boy tells us what to put in there. Hafen-Square, yes. Hafen-Square, come get your pudding. All right, anyway, that's my bad impression of a German lady. So what would a good number be to put in this box? Well, half of this and then square it, which would be what? 1. And if I put 1 there, I gotta put 1 there. And then, hopefully you knew, I'm going to just do it the long way. This part, don't talk please, this part is the part that will break down into the perfect square, x plus 1 and x plus 1. And then this part right here goes together and makes plus 6. And then the final answer, if I'm going to carry my work all the way through, is x plus 1 quantity squared plus 6. And now I see the vertex. -1 comma 6. Raise your hand if you get that. All right, that's almost everybody. So, and the one person wasn't paying attention. That's a big deal. He will, though, in the future. Okay. Now, what happens, though, if it looks like this? Actually, make it like 4x plus 7. Okay, write that one down. This is the harder kind. The kind that you can't just wake up in the morning and do before you have breakfast. So, let me give you some help. You start the exact same way. 2x squared plus 4x plus a box minus a box plus 7. But we cannot continue like normal because what's different about this one that seems important? Yeah, there's that 2 in the front. And that 2 would mess things up. Because you remember how when we're done, we want this to be 2 that are exactly the same, like x plus 3 and x plus 3. These have to be exactly the same. Can you think of anything that could be exactly the same that would be times together would make 2? That's why you can't do this. Okay? So we don't want that 2 there. We have to have it just a plain x there. So what that means is we have to get the 2 out of there, which means we should do what? Yes, we can divide everything by 2, which is called factoring it out. Now, notice that has a 2 in it, and that has a 2 in it, and that doesn't. Does that pose a problem? No. It's totally okay. Let me digress for just a moment. Let's say that I had this, 2a plus 2y minus 7. What do these two have in common? And I could factor out the 2 and put a plus y and then a minus 7 at the end. There's nothing wrong with that. You don't have to have something go into everything to be able to factor it. If I want to factor it out of just these two things, I can. And that's what you do. You just factor it out of the first two. So 2 goes into both of them, so you can take the 2 out, and then what do I have left? I have x squared plus 4, and I know you're going to be, sorry, 2x, but I know you're going to be tempted to put the end parenthesis right there. Don't. Because we're just going to include this box first and then put the parenthesis in. You know why? Because that's where half and square is going to go, and we need it to make our perfect square. We need 3 parts here for our perfect square. And then, let's see, minus box plus 7. And now, notice I didn't figure out half and square until after I factored that 2 out. Now I'm going to figure out half and square. Half of 2 is 1. 1 squared is 1. Happened to be the same as last time. And this looks just like the other problem we did, except it has a 2 in the front. So can you just kind of do the rest of this, shortcut it, and say x plus 1 squared, and then plus 6. Do you get that? And some people think this somehow changes your vertex. It does not. The vertex is still negative 1, 6. Okay? All right, so summary. Go back to the beginning here. What did I do different? Aha! I have to do something different because there's a 2 in front. I will still put in my plus box, minus box. Then I will factor something out of just the first 2 terms. Notice the 7 doesn't have anything factored out of it. And then, oh, I even forgot something important. Yay, and I'm recording too. Okay, as long as the person's still watching the recording, they're going to be fine because I'll help them. But I forgot the thing that people always forget. All right, there's one little change. You'll have to go back and tweak one number in your example on your notes. Okay, and it's a great example of always forgetting it because even the teacher does. Okay, this box and box, why are they there again? They're there so that they cancel each other out. If I add 6, then I got to take away the 6, right? What smart kid can figure out what's wrong with this situation? Ooh, 2 smart kids. 3, 4. What do you think? I didn't factor that 2 in out of it or into the situation. This 2 here, when I times it by that 1, isn't that gonna make that really worth 2? And so to counteract that, I have to make this one worth 2 times as much also. Okay? See what I mean? Like this and this are supposed to cancel each other out, but this one's going to get multiplied by 2. So I have to multiply this one by 2 also. Otherwise, it won't keep the equation balanced. So what does that mean? That means 2 times negative 1 would make negative 2, and the negative 2 plus the 5 would make, or sorry, plus the 7 would make 5. So I was wrong. This problem was not exactly the same as the other one we did. All right. And it's really easy to forget that, obviously. So let's do another one. Y equals negative x squared plus, let me think, 6x plus 1. Okay. So I'm going to pause for a second because I have a question. Yes? For the previous question, yes.
Wouldn't the other one be 2 as well? Would you leave one and there's 1 and the other one's 2?
You can, I know you're thinking that I haven't multiplied this out, but I actually do because the 2 is still here. So they're both getting multiplied by 2 now that I put a 2 here. So it's okay. All right, on to this one. So what's different about this one? Why can't I just do this like the normal complete the square? Because of that. How do I get rid of it? Factor it out. So first step was to put in your boxes. Plus a box, minus a box, plus 1. Okay? So that's still the normal thing. Now, Josh, what do I factor out of this thing? Negative what? Negative 1. And when I do that, I have what left? X squared Negative 6x, yep. And my box, I really can't factor anything out of a box, right? So it's still a box. And then minus a box plus 1. Now, I don't have to worry about my plus box, minus box until I do half and square. So let's do that. What's half of negative 6? Negative 3 squared. 9. So there's a 9 and a 9. And now I have to be careful. Do not make that same mistake as last time. Last time I forgot, since I had this, I need to also have one here. And that's a multiply, in case it isn't clear. So that would become positive 9 at the end. All right, so next, I don't need to do that yet, though. Next, I'm going to just say y equals negative 1, and then do this part. And then I'm going to do plus positive 9 plus 1 makes positive 10. Okay, and now this part is the x and the x. And then I got to be careful here. You always take the square root of the 9, which is 3 and 3. But I've been used to doing pluses, but in this case, minuses. Now why? You can see there's a minus right there. So then, final answer, negative 1, x minus 3 squared plus 10. What is the vertex of this one? 3 comma 10. So we have taken something in general form, and we've written it in vertex form, and now we know the vertex. Okay. All right, so those are just a little more complicated completing the square problems. Last one, this one we're going to do tag team, and I'm going to ask people to do different parts. This one. This is going to be a tough one. All right. Who wants step 1? So you know it and it's easy and you want to get it out of the way. Jay. There's actually a step before that. You're trying to, actually that's a harder step. This is easiest. What do you do to start, Josh? You put the boxes in. In a way, yeah, he messed up, but it's only because he was trying to do a harder part. That's good. Okay, so now, go ahead. All right, we're going to factor out that 7. Notice I'm going to put parentheses around that whole area. Wait, would that be 3? Yeah. And probably right now, before I forget, what should I do? 7 times whatever's in that box. Even though I don't even know what's in the box yet, I know it's going to have to be 7 times that big because I have a 7 here. All right. Next step. Who knows what to do? Don't be shy. Yes. All right. Half and square. Tell me what to write. Yeah. 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 As in the half and square. Excellent. Even spoken with a German accent. Much appreciated. Okay. And then over here, I may as well just go ahead and square it. And what's 3 squared? It's 9. Over 2 squared is 4. So I'm going to put 9/4 there. All right. Now, why did I leave this as negative 3 over 2 squared? Because I'm about to take its square root anyway when I do this part. X, and these have to be minuses because there's a minus this time. And the 2 negatives will make positive that. Okay, but now I can see my square root. See, if I'd have written 9/4 there, I might not have remembered that it was 3 over 2. And now I got to do 7 times 9/4, which is 63/4, and it's negative 63/4. That's too much to try to keep in my brain, so I'm just going to do that, plus 2. And then I'll combine it all together at the end. Y equals 7 times x minus 3 over 2 squared. And then I got to put those together somehow. I need a common denominator, which would be probably 4ths would be smart. So I'm going to put this over 1 and multiply by 4 over 4. That'll make it 8/4. And the negative 63/4 gives me negative 55/4. And it'd be fine with me if you want to leave your answer like that. If you grabbed a calculator in your weakness, I would understand. Okay, so that's about as hard as they could possibly get. Because it involves negatives, it involves fractions, it involves factoring things out. Okay, and most of your problems aren't going to be that hard. All right? Notice two places that people screw up on this. Number one is they forget this, like I did on the first problem. Number two thing they screw up on is they try to do half and square right away, and that doesn't work. You got to wait to do the half and square till down here after you've already factored stuff out. Then you can do half and square. Okay? All right, there's the keys to today, and I got a worksheet for you. It's like worksheet B, I think we call it, on completing the square.